A rod of weight W is supported by two parallel knife edges A and B and is in equilibrium in horizontal position. The knives are at distance d from each other. The center of mass of rod is at x from distance x from A. The normal reaction on A is, एक rod ये सपोर्टेड है टू नीव्स पर A एंड B. इसका CG center of mass is at C and AC is X and AB is D. Weight W. Reaction at A news is RA and normal reaction at B is RB. Moment of force is about B. क्लॉकवाइज डायरेक्शन को पॉजिटिव लें, एंटी क्लॉकवाइज डायरेक्शन को नेगेटिव. तो आर ए इंटू डी माइनस डब्ल्यू डी माइनस एक्स प्लस आर बी इंटू ज़ीरो, दिस विल बी ज़ीरो क्योंकि रोड इज इन इक्विलिब्रियम. आर ए into D minus W D minus X plus 0 is equal to 0. RA into D is equal to W D minus X. Reaction at A, RA is W D minus X by T. This D is correct option. Next, a mass M moves in circle on a horizontal smooth plane with velocity v dot at radius r dot. The mass is attached to the string which passes through a smooth hole in the plane shown. The tension in the string is increased gradually and finally M moves in a circle of radius r by 2, r dot by 2. The final kinetic energy is the velocity is v dot initial and r dot. Initial angular momentum is m v dot r dot. अब स्ट्रिंग को पुल किया जाता है और रेडियस इज रिड्यूस टू r by 2, r dot by 2. This r1 is equal to r dot by 2. The position vector r, this r is like this and tension in the string is ये ऑब्जेक्ट है तो टेंशन होगी दिस टी वेक्टर. तो torque applied will be r dot t or rt sine 0 sine 180, and 180 is 0, hence this is 0. Torque on object is 0, hence angular momentum will be conserved. Final angular momentum, अगर इसकी velocity is v1, that will be mv1 r1 or mv1 r dot by 2. For conservation of angular momentum, LF is equal to Li mv1 r dot by 2 is equal to mv dot r dot. So v1 is 2 v dot. Kinetic energy half m v1 square or half m 2v dot by square. This is 2 mv dot square, and this C is correct option. Next, three identical sphere cells, each of mass m and radius r, are placed as shown. Consider an axis xx which is touching two cells and passing through diameter of third cell. Moment of inertia of the system consisting three spherical cells about xx is cell A, cell B and cell C. Ixx होगा moment of inertia about of cell A about xx, Ia moment of inertia of cell B about xx is Ib, and moment of inertia of C about xx. Ia होगा, this is cell 2 by 3 mr square, and this distance from x-axis is d is equal to r. B का होगा 2 by 3 mr square plus m d square, and C का होगा 2 by 3 mr square plus m d square or 2 by 3 mr square plus 2 by 3 mr square mr square plus 2 by 3 mr square plus mr square. 2 by 3 mr square plus 5 by 3 mr square plus 5 by 3 mr square. 3 2 plus 5 plus 5 mr square 4 mr square. This D is correct option. Next, point masses m1 and m2 are placed at opposite ends of a rigid rod of length L and negligible mass. The rod is set to rotate about an axis perpendicular to it. The position P on the rod through which the axis should pass, so that work required to set the rod rotating with angular velocity omega dot is minimum, is given by. Moment of inertia about point A and perpendicular to this AB rod will be m1 x square plus m2 L minus x square. Work done is equal to rotational kinetic energy, and that is half IP omega dot square. Half m1 x square plus m2 L minus x square omega dot square. For W to be minimum, dW by dx must be 0, and this is half omega dot square 2m1 x1 plus 2m2 L minus x into 0 minus 1, or 2m1 x1 minus 2m2 L minus x must be 0, or m1 x1 minus m2 L plus m2 x is equal to 0, m1 plus m2 x x is equal to m2 L, and x is equal to m2 L by m1 plus m2. D is correct option. Next, for f alpha I cap plus 3j cap plus 6k cap acting at point 2 I cap minus 6 j cap minus 12k cap. The value of alpha for which angular momentum about origin is conserved. For conservation of angular momentum, torque must be 0, or 0 I cap plus 0 j cap plus 0 k cap. Torque is equal to R cross F, or I j k 2 minus 6 minus 12 alpha 3 6 is equal to I minus 6 into 6 plus 3 into 12 minus j cap 2 into 6 plus 12 alpha plus k cap 6 plus 6 alpha. This must be 0 I cap plus 0 j cap plus 0 k cap, or 0 I cap minus 12 plus 12 alpha j cap plus 6 plus 6 alpha k cap must be 0 I cap plus 0 j cap plus 0 k cap. Comparison करेंगे तो this must be 0 and this also must be 0. So 12 plus 12 alpha must be 0, so alpha is minus 1. अगर सेकंड को लें 6 + 6 अल्फ़ा इज़ 0 तो अल्फ़ा इज़ -1, तो अल्फ़ा की वैल्यू इज़ -1, ए इज़ करेक्ट ऑप्शन। Next, an automobile moves on road with speed 54 km per hour. The radius of wheel is 0.4 meter and moment of inertia of the wheel about its axis of rotation is 3 kg meter square. If wheel is brought to rest in 15 seconds, the average torque transmitted by the brakes to the wheel is. Speed of the wheel is 54 kilometer per hour or 54 into 5 by 18 meter per second, 15 meter per second. Rotational angular velocity will be v by r or 15 by 0.45. 15 0.45 into 100 डेसिमल हट जाएगा 3, 100 by 3 radian per second. Initial angular velocity is 0 and time is 15 seconds. इसमें रेस्ट में आता है तो ओमेगा इज इक्वल टू ओमेगा डॉट this is omega dot and final is this omega is 0 minus alpha t. 0 is equal to 100 by 3 minus alpha into 15. Alpha is equal to 100 by 3 into 15. 20 by 9 radian per second square. Moment of inertia I is 3 kg meter square. The torque required is I alpha or 3 into 20 by 9, 20 by 3, 6.66. A is correct option.